You're listening to Emma equals MC squared, a podcast where I can help you learn or review about science in a fun and fast way too. Please leave a comment or review in the comment section below so I can help others learn about science in a good way. I'd like to keep these as ad-free as possible, so please support me by checking out my store link in bio, where I sell lots of fun posters and products, and some of them do, in fact, relate to the podcast. Now, to the episode. Hello, and today we are talking about the atom, one of the most fascinating things ever. Obviously, it's fascinating and important because it's the basic of everything. Everything is made out of an atom, so clearly it's important, and it seems like a pretty solid thing to start off the first episode with. This may seem simple, but it took over 1,000 years for people to figure it out. It started in 400 BC with Democritus, who believed it was the smallest thing ever and that there was nothing inside the atom. Over 1,000 years later, in the 1800s, John Dalton thought that atoms were indestructible. However, that was disproved with the atomic bomb, and Democritus' theories were also disproved later on, so they weren't entirely right with these. However, John Dalton was correct with some other things, like the atomic weight and how it should be on the periodic table. In fact, today it is still organized by the atomic weight of elements. Also, he believed that elements combining will form new compounds, such as water. After him, about 90 years later, J.J. Thomas discovered the electron, and he did this with a cathedral ray tube, a very fascinating experiment. He ran electricity through a tube with little air to avoid other distractions and possible errors, and they had deflection coils, positive on the top and negative on the bottom. And the electron beam went to the positive, showing that the electrons are negatives, because positive and negatives attract, like with magnets. He has one of my favorite names for models of atoms. It's called the Plum pudding model, and it's named this due to the fact that it's just electrons in a circle of the atom, and so it looks like pudding. This time it only took 20 years later, in the 1910s, for Ernest Rutherford to discover the nucleus with his gold foil experiment. A very cool experiment, if you ask me. He shot alpha beam particles through gold foil with a metal ring around it. He expected the alpha particles to go straight through if there was no positive thing changing the gold foil. However, some of them were deflected, showing that the gold foil had a positive center, which is the nucleus. That's how he discovered that the nucleus was there and that it was positive. The next discovery was in the same decade as him, Niels Bohr. You might recognize this name by one of the most popular models there is, the Bohr model, where the electron has orbits around the nucleus. In fact, this biggest discovery that turns out to be not 100% accurate, but still, he depicted the orbits of the electrons like planets around the nucleus. 10 years later, we have the last discovery of the atom by Erwin Schwarzenegger, and he discovered that the electrons don't have an exact orbit around the nucleus, but more of a cloud of probability. Kind of think of an airplane in a cloud. You know it's in there, but you don't know exactly where it is. That's kind of what he's saying, that the electron is in the cloud, you just don't know where it is, so it's more of a cloud of probability. Now that we have the history done, I'm just going to explain a few brief things about the atom that will be helpful to know. First, we have the isotopes, which are elements with a different number of neutrons. Now, it can't be a different number of protons because protons determine what kind of element it is. So if you have two more protons to, say, hydrogen, then the atom would be lithium, which is entirely different. So you write this with the element symbol, like carbon, for example, C for carbon, and then dash in the atomic mass. For carbon, it's normally C-12, but if you add two neutrons, it's C-14. Now we have cations and anions. Think cations as positive, because it's a cat, and think of anions as negative. I don't really have anything for that one. You can tell which ones they are by the columns they're in. Hydrogen, beryllium, and boron are all cations, and helium is one too. Nitrogen, oxygen, and fluorine are anions. Now, one last quick thing before you graduated is valence electrons. They are electrons in the most outermost cloud. I'll talk more about this in a later episode, but I just thought that I mentioned it now. So that's about the atom. We went through a bunch of history, over 1,400 years, and a little thing about isotopes, cations, and anions, and a little brief introduction about valence electrons. I hope this helped you, and see you later. Thank you so much for listening. I really hope this helped, and thank you so much. I really appreciate you listening to this. Be sure to leave a comment below and let me know how I can improve, and to check out my store. Until next time, Emma equals MC squared, out.